Hi, Honors Chem students. This video is on how to solve mole-to-mole stoichiometry problems with limiting and excess reactants. So in this video, I'll be going over this example problem. You've balanced this one many times, but we'll go through the process. So on the left-hand side, there are 2 nitrogens. On the right-hand side, I see only 1. So in order to get the same number of nitrogens, I'm going to put a 2 here. Now we have 2 nitrogens, but we now have 6 hydrogens, 2 times 3. So we have 6 hydrogens. So to balance the hydrogens, I'm going to put a 3 here. And just to make my coefficient clear, I put a 1 in front of the N2. Part B says, if 3.5 moles of N2 gas are reacted with 7.3 moles of hydrogen, what is the limiting reactant and what is the excess reactant? So we're given these amounts of N2 and H2. Hydrogen here is H2. And we want to figure out which reactant is going to be limiting our reaction, which one is going to get all used up, and which reactant will have some left over. So the way I'm going to do this is I'm going to see that I have 3.5 moles of N2, and I want to see how much hydrogen is needed to react all of my 3.5 moles of N2. So if I react all the N2, in order to figure out how much hydrogen I need to react all the N2, I'm going to use my ratios here. And I see that for every 1 mole of N2, I use 3 moles of hydrogen. So I can put on top here 3 moles of hydrogen for every 1 mole of N2. That will cancel out my moles of N2. And now I will have 3 moles of hydrogen times 3.5. And that will give me 10.5 moles of hydrogen. And so then I see up here that actually I only have 7.3 moles of hydrogen, and I need 10.5 moles of hydrogen. I don't have enough hydrogen here. So I can write that since I have less than 10.5 moles of hydrogen, the hydrogen is the limiting reactant, right? I don't have enough to react all of the nitrogen. And the N2 is my excess reactant. Okay, so, and notice it says show your work. Okay, that's really important for these problems. It demonstrates that you understand how you're getting these amounts. And for this limiting reactant versus the excess reactant, you also want to include some kind of explanation here, such as this, that shows, how you figured out which thing was the limiting reactant. All right, so again, let me just emphasize again that these numbers right here, right, this ratio is coming from the balanced reaction. That one goes over here. Very curvy arrow. All right, so that was part B. So let me just put the numbers that we found from the previous part here. And our limiting reactant is the hydrogen. The excess reactant is the nitrogen. So in part C, they ask how many moles of NH3 are produced from the amounts in part B. Use a BCA table. So we'll set up our BCA table down here. And we'll put our balanced reaction on top. Let me put a 1 here. And then I'm going to look back in part B. And I see that I have 3.5 moles of N2, 7.3 moles of hydrogen. So I will put those amounts in my before row in my table. So that's going to be 3.5 moles of N2. Here we have 7.3 moles of H2. And before the reaction starts, I have 0 ammonia. I'm going to just label my H2 as my limiting reactant, and this is my excess reactant. So the next step is to fill in the change line. So I'm going to first get rid of my limiting reactant, right? Because if this is limiting, it's going to be 0 at the end. So I'm going to have 0 at the end here. Now, my change in my nitrogen in my N2 is based off of the limiting reactant. Okay, my change in my NH3, my ammonia, is based off of the limiting reactant. I can't make more ammonia than what my limiting reactant provides, and I will use the amount of nitrogen necessary to react all of my limiting reactant. Okay, so in order to figure out the change, I first start off, this is going to be plus because I'm producing it. First, I'm going to put in my change here, okay, 7.3 moles of hydrogen, okay. I'm basing this amount off of the change in the hydrogen, and I just need to change this into ammonia by using my ratios, right? For every 2 moles of ammonia, I use 3 moles of hydrogen, right? I'm getting these numbers from my balanced reaction here, right? My balanced reaction is giving me my ratios. So let me just do the math here. 7.3 times 2 divided by 3 will give me 4.9 plus 4.9 moles of ammonia, because my moles of hydrogen cancel out. All right, so there's my change for my ammonia. Let's fill in the change for the excess reactant. So here our change is going to be negative because it's one of the reactants. So we're going to take my change in the limiting reactant, the 7.3 moles of H2, and we need to change it to the amount of nitrogen necessary by using the ratios. So here we know that 1 mole of N2 is reacted with 3 moles of H2. And when we take negative 7.3 divided by 3, we get negative 2.4 moles of N2. Okay. Sorry, that's a little cramped. But again, here, these ratios, right? This ratio, 1 to 3, is coming from the coefficients in the balanced reaction right there. Okay. So now finally, once I've figured out my change, I can calculate my after line by taking 3.5 minus 2.4 to get 1.1 moles of N2. Over here for the ammonia, I take 0 plus 4.9 moles of NH3, and I end up with 4.9 moles of NH3. So now that we've finished filling in the BCA table, let's go back to part C and write down our answer. So it asks how many moles of NH3 are produced from the amounts in part B. So that's shown in our BCA table. So for part C, we can see that we produced 4.9 moles of NH3. And then if we look at part D, it says how many moles of the excess reactant are left over after the reaction is complete. So for part D, our excess reactant is our N2. We can see right here in our table that 1.1 moles of N2 are left over. We could also answer how much of the excess was reacted away. So that would be 2.4 moles of N2. We can see that the limiting reactant is gone. So our BCA table gives us the answers to C and D. So now for homework, you should solve number 2 and 3 on paper. Make sure you show all of your work. Take a picture of it when you're finished and attach it to the Google Classroom assignment. So in this question, the excess is identified for you. So the NO is the excess, which means that the O2 is the limiting reactant. Pause the video here and do this problem. Here's question 3. So again, make sure you show all of your work on paper for this problem. This problem is very similar to the example that I went over in the video. Pause the video and do the problem on paper. So if you're still struggling with mole-mole stoichiometry problems, make sure to reach out to your teacher, go to office hours, or email them with your questions, and ask questions during class tomorrow.